morning, everyone, and welcome to our World Ocean Day broadcast. No better way to celebrate than with our final Reefs Go live episode of this season. We're coming to you live from one of my favorite dive sites, Jackson Reef, here in Little Cayman. My name is Balt. I'm a member of the operations team here at CCMI, and I get to be your topside host for today as we talk about climate change and its impacts on our ocean and how actions we take can support the health of our ocean. Now, during our broadcast today, our team is going to be sending me your comments and questions from the chat, so you'll see me keeping an eye on my phone as we go so we can answer those questions. Our underwater host today is Chandra. She will be wearing a specialized scuba mask so that we can talk back and forth while she's underwater. So let's go ahead and say hello to Chandra. Hi, Chandra.
Hi everybody, and welcome back for this very special World Ocean Day broadcast, especially all of you in Canary Cinema right now. As Bolt mentioned, we're on Jackson Reef, and we hope we can show you just how important this environment is to us and future generations. So as always, we do want to know where you guys are from and where you're joining us from, so pop it in the chat along with your name, and we'll give you a shout out a little bit later on in the episode. So, we mentioned it's a World Ocean Day episode, but official World Ocean Day is not until the 8th of June, which is on Sunday. But in our line of work, every day is World Ocean Day, right, Bolt?
That's absolutely right, Chandra. I'm just going to have a quick look in the chat and see if I can see where people might be joining us from. Again, a big shout out to everyone watching from Camana Bay Cinema in Grand Cayman. I'll take a look at the chat as I get some responses there. Great to have you all with us. Now, World Ocean Day started about 30 years ago as a way to recognize the importance of the ocean and as well as our responsibility to protect it. And what it reminds us is that the oceans are not just important to protect for their own sake. The oceans are where life on this planet first began, and they are still vital to all life on land in ways that we may not always realize. Now, just to give you an example, the ocean plays a huge role in regulating the Earth's temperature. The ocean is massive. It covers 70% of the Earth's surface, and it absorbs over 90% of the excess heat on the surface. And that keeps the temperature for all those of us living on land nice and stable. Without that, it would be hard for life anywhere to survive. And the ocean is also the beginning of what's called the water cycle, which is the large global process that brings fresh water to all of us on land. Now, Chandra, would you like to explain a bit more about the water cycle?
Sure, Bolt. So, we do all know that without water, life on Earth would not be possible. So, the ocean holds about 97% of all water on Earth, and this is kind of where the water cycle begins. Heat from the sun obviously heats up the ocean and the water evaporates. As the vapor cools, it condenses to form clouds, and when these clouds become too heavy, it releases the water in forms of rain and snow, which fill our streams and lakes. It waters our plants, and it also provides fresh drinking water for us and animals. And as I mentioned, this all starts with the ocean, which is fighting many threats like climate change, right, Bolt?
That's exactly right. Thanks, Chandra. Now, in a moment, we'll take a bit of time and talk about what climate change really means. At the moment, I'm seeing some shout-outs in the chat here. Greg Loker, joining from North Carolina. Hi, Greg. Charlotte and Oliver from Oregon. Denise from Saranac Lake. Melanie Carmichael from Grand Cayman, interested in learning about the current health of our reefs. Jim from the Upper Peninsula, Year 4 of Island Primary, Mrs. Carmine's class in Connecticut, U.S., Yvonne from France, Alex from Virginia Beach, my dear mother Catherine from Maine, Tim Carey from Florida, Year 5 teachers and students from Red Bay Primary. Great to see you all. Denise, who was diving in Little Cayman a few weeks ago and enjoyed the reefs here, from Grade 2 CIS. Year 6 group from Marie Martin Primary School, watching from the cinema. As I recall, it's the birthday of Cayman from a a group we have from Saginaw State University in Michigan now, so happy birthday. They're a group that's visiting us here at CCMI. Again, great to have you all with us. Now, I'm going to take a moment here and talk about climate change and what that really means. Climate refers to a long-term pattern of weather, something like temperature or rain or wind. For example, the Cayman Islands have a tropical climate, which is hot and humid, and it has a dry season and a rainy season. Climate change is when those patterns start to shift over time, and that can happen naturally. It can happen over thousands or millions of years. But when we talk about climate change nowadays as an environmental problem, we're generally talking about the overall warming of the Earth. You may hear the term global warming for that reason, caused largely by carbon dioxide, or CO2, which is an invisible gas. Trace amounts of it are in the air around us, and it's natural. We breathe it out all the time. What it does, it traps heat in the atmosphere like a blanket. And when you add CO2 to the atmosphere, that actually increases the temperature of the Earth. And nowadays, we release a lot of CO2 unnaturally by burning fossil fuels, which we use to power things like cars and ships and planes and factories and to generate electricity. And what this means is that even simple things we do, like turning on the lights or buying something that was made in a factory, all of that results in CO2 being released somewhere. And all of that adds to what we call our carbon footprint. Now, take a moment and let us know in the chat if you can think of any impacts of climate change off the top of your head, and we may talk about some of them later in the episode. Now, adding more CO2 also has some impacts on the ocean. Some of that CO2 gets dissolved in the oceans, and this actually makes the oceans more acidic. It creates what's called carbonic acid, and this is a problem, because carbonic acid is really good at dissolving minerals, especially one called calcium carbonate, which are very important for a lot of marine life. For example, they make up the shells of shellfish, crabs and conchs and lobsters and that kind of thing. And more acidic seawater will weaken those shells and make it harder for those animals to survive. This is actually basically the same reason why your dentist will tell you to stop drinking soda, because soda is acidic, dissolves the calcium in your teeth, and gives you cavities. And something similar can actually happen to coral. Chandra, would you care to explain more?
Well, corals use calcium carbonates to build their hard skeletons, and as they grow, it turns into limestone. Now, this limestone takes thousands of years of growth, and it creates structures like these amazing ones that you see around me today. Now, here in the Cayman Islands, the entire landscape is made up of just about entirely limestone. And that basically means that our roads, the infrastructure, houses, schools, are all built on ancient coral reefs. And that's quite amazing to see, but the problem with this is when the ocean becomes more acidic, the limestone can begin to dissolve. Right, Bolt?
Yes, that's right. And our education team sent out a worksheet that some of you may have seen that shows an experiment you can do at home to visualize this. If you take a seashell right off the beach, you'll notice it's solid, it's hard to break, it's made up of calcium carbonate. And if you take it and you soak it in something like vinegar, which is acidic, simulates ocean acidification, you will see it becomes much thinner, much weaker, and easier to break as that calcium carbonate dissolves. And you can see with your own two eyes what a danger ocean acidification is to marine life that depends on those shells. Things like shellfish, corals, even some tiny plankton. I'm going to go ahead and check the chat briefly for questions on that note. I see, a lot of questions. Okay. How is, excuse me just a moment here. There's a question, how is CCMI protecting the reefs on a daily basis? A number of ways. CCMI actually has a coral nursery, like a little garden, where we grow staghorn coral, which is a fast-growing coral that used to be very abundant around these reefs, and which we, once it grows big enough, can outplant back onto the reefs it came from, just as an example. Let me see some other questions here. How long has CCMI been in existence? We were founded in the late 1990s. Let's see. St. Ignatius is studying climate change right now. They add it causes global warming and ice cap melting. Yes, those are very good points. The ice caps melting are another important impact of climate change. Excellent questions from all of you. I may double back to some of these later. Let's go ahead and talk for a moment, separate from the issue of ocean acidification, is the issue of the ocean's warming. Now, as we mentioned before, the addition of carbon dioxide to the atmosphere causes the atmosphere to warm, and that also warms up the oceans. Chandra, can you tell us more about recent trends in global warming?
In this graph, you can see that there has been a global increase of temperature, but since 2020, there was more of a drastic increase in these temperatures. In fact, 2024 was the hottest year recorded, and every month broke a new heat record. So that's kind of what's happening with the temperatures there, Bolt.
Yes, thank you. And that's a big problem because nature does not have time to adjust when the temperatures change that quickly. Many ecosystems are affected, and coral reefs in particular are in danger from an issue known as coral bleaching. Chandra, are you okay to talk a little bit about what coral bleaching is?
We did speak about coral bleaching in a lot of our previous episodes, and we learned that our corals have a tiny symbiotic algae living in their tissue, which give it about 95% of its nutrients. So when this algae becomes stressed from rising temperatures, the coral expels the algae because it becomes toxic. And this does then this reveals that bright white skeleton beneath the coral tissue, and it's why it's called coral bleaching. And this is quite heartbreaking to see.
Yes, it is heartbreaking. In 2023, there was a major heat wave all around the Caribbean. The water got really hot, and that resulted in a lot of coral bleaching and, unfortunately, coral death. Now, CCMI's research team actually documented this bleaching event in the coral health surveys of the Healthy Reefs program that they run here at CCMI. And we have results now from 2024, which was the hottest year on record, which show the impacts of that bleaching event. You can see it decreased live coral cover on the reef from 28% to just around 10%. And this is the most severe loss of coral since CCMI's records began. And, you know, it may sound like we're just throwing around numbers, right? 28%, 10%. But the reality is these are living creatures we're talking about. And I can speak a little bit from personal experience. I moved to Little Cayman in 2023, and I got to watch this bleaching event unfold firsthand. And as Chandra said, it was heartbreaking. You know, it really made it clear what can happen to our ocean's ecosystems when the water gets too hot too fast. But there is still hope for the future of Cayman's reefs. Those same reef health surveys also found significantly increased fish populations, particularly things like parrotfish and grouper, which are good indicators that the ecosystem more broadly is still healthy and could recover with the right interventions. Furthermore, a lot of the coral that died in 2023 were fast-growing coral, which can recover more easily. Things like lettuce coral. Small, fast-growing, and you start to see them around the reef again now. And a lot of the large reef-building corals, some of the ones you're seeing around Chandra underwater there, those actually survive the heat wave, and that gives us hope. But the bottom line is that CO2 emissions are going to pose problems for these ecosystems, and it's important to understand how that can be mitigated. Isn't that right, Chandra?
Exactly. So oceans do help by absorbing CO2 into their sediment or passing it on to marine plants like seagrasses, mangroves, and algae. Now this is a natural carbon storage, and it's known as blue carbon. As I mentioned, it's a natural process, but with rising CO2 levels, we do have an urgent need to find ways and help the ocean either enhance or improve its ability to absorb CO2. This has led to a number of projects aiming at using blue carbon to help fight climate change, and many companies are looking at blue carbon or exploring that option to help offset their own carbon emissions. Bolt, can you explain what this means?
Yes, I would love to. Carbon offsetting is the use of natural carbon storage to compensate for carbon emissions. It's not something that solves climate change by itself, but it can be a useful strategy. And the way it works is, a company that owns maybe a number of factories with a lot of CO2 emissions may take some of its profits and use that to help plant trees or protect forests somewhere else in the world, which, as they grow, will take in carbon dioxide and compensate for that company's carbon emissions. And the ocean has huge potential to be used for this kind of thing, because the ocean already cycles and stores almost a third of global carbon emissions. But there hasn't been that much research as of late into how you can practically use the oceans for carbon offsetting. And this is why CCMI is investigating that now. In just a moment, Chandra will tell us more about CCMI's blue carbon research. I'm going to take just a second and check the chat for some questions because I see some good ones. Let's see. I see a clarification for... a question from a CIS student. How much coral was bleached in Cayman during the heat wave? 95% bleached, 50% died, the rest recovered. It's important to note, just because a coral is bleached does not mean it is already dead. If the temperatures go down, it can recover. There's a question from Red Bay Primary School. Can food help increase CO2? Let me say this. There is a lot of CO2 released in the process of growing and producing food. Now, growing crops may actually take in some CO2 because you're growing plants, but processing food, transporting it, releases a lot of CO2. And animal agriculture can release a gas called methane, which is also a greenhouse gas, works similarly. Let me see. Where does calcium carbonate come from? That's a good question. Calcium carbonate, so calcium, among other minerals, is just dissolved in the seawater. The seawater has a lot of things dissolved in it, a lot of minerals, that's why it's salty. And organisms that use calcium carbonate are able to extract that. Their bodies extract that from seawater, just like our bodies use calcium from food to produce bones and teeth. Let's see. I'm seeing my dear mother from back in Maine asks a question she knows will stump me. Does ocean acidification affect the coral's symbiotic algae? So as Chandra said, symbiotic algae are important for corals. That's the problem with coral bleaching. I don't know off the top of my head how water pH impacts those algae, so I'll have to look it up. Thanks, Mom. Let's see. For the impact of climate change, from Year 5 and Sir John A. Cumber Primary. They say climate change affects the oceans by causing rising sea levels, warmer ocean temperatures, coral bleaching, acidification, and disrupted marine ecosystems, which disrupt sea life, coastal communities, and weather patterns. Yes, that is all very correct. Climate change poses a number of problems, including sea level rise from melting ice caps, and other things that can damage coastlines where a lot of people live. What monitoring and research methods are used to assess the health of the coral reefs? So, for example, when our research team does those coral health surveys, and Chandra, if you want to answer any of these, please jump in. They're basically taking a long tape measure and a PVC square, and they're going along the reef, and they're essentially counting and measuring how much coral, on average, you find in a given area. And that goes into these live coral cover percent numbers. Do greenhouse gases produce heat or trap heat in the atmosphere? They trap heat. The heat comes from the sun, and the heat radiates back off from the Earth's surface, and that is what these greenhouse gases trap and reflect back down to the surface. That's a good point. They're not producing heat necessarily. They're just like a blanket. Excellent. So I will get back to the questions in a bit. Let's talk for a moment about CCMI's blue carbon research. Chandra, do you want to talk a bit about that?
Sure. So CCMI has a blue carbon offset project that was sponsored by Butterfield, and it began in 2023. Its goal is to find the best ways to use blue carbon to help fight climate change. And CCMI researchers are basically conducting experiments to find the best ways that carbon can be absorbed into carbon sinks, such as seagrass meadows, and also how these habitats can work together to potentially increase the way carbon is being stored. So by measuring how much sediment ends up in sediment traps, CCMI is learning how to improve this absorption process along coastlines. So now there are two ecosystems in particular that can store more carbon than most. Bolt, would you tell us about these, please?
Yes, let's start by talking about seagrass. Seagrass is the only flowering plant that lives in the ocean. It lives in calm, sunlit waters, just like the lagoons of Little Cayman, where you find a lot of it. It supports life such as juvenile fish and sea turtles. And just like land plants, seagrass take in carbon dioxide to grow. And even though seagrass meadows cover just 0.1% of the ocean floor, they store a lot of carbon, up to 35 times faster than tropical rainforests like the Amazon. And in seagrass, this carbon gets trapped in their leaves and their roots and buried in the seafloor for the long term. And another important ecosystem that traps carbon is mangroves. Chandra, can you talk about mangroves?
Of course, mangroves are quite unique environments that have trees that can thrive in a salty kind of water. They're not as eye-catching as what the coral reefs are, but it doesn't mean that they are just as important. So mangroves can be found in brackish waters where the land meets the sea. And they can store up to about 4,000 tons of carbon in the same space as a rugby field, which is quite amazing. They have large tangled prop roots which keep sediments in place, and this prevents any of the carbon dioxide from breaking down and being re-released back into the atmosphere. So you've mentioned seagrasses and I've spoken about mangroves, but there are threats that could damage these ecosystems. Walt, could you tell us about the threats?
Yes, I'd love to. Sadly, these coastal ecosystems are often damaged or destroyed by coastal development when we build things like roads or hotels or ports. And when that happens, all the carbon that's been stored gets released back into the atmosphere where we do not want it. And cutting down mangroves, for example, every year releases around 20 million tons of carbon, and that's equivalent to the pollution from 4 million cars. So you can see that protecting these ecosystems is one of the most important ways in which we can fight climate change. I'm going to take a moment here and look back at the chat. Chandra, here's some questions you may have some ideas about. Forwarded from CIS students and from Year 4, Joanna Clark. One question: if all coral died in the ocean, would all the fish die too? Chandra, do you have any thoughts about that?
I do have a few thoughts, Paul, thanks. Well, if all the corals died, that would be a loss of habitat, and if there's a loss of habitat in any kind of environment, whether it be in the sea or on land, the animals around would obviously lose their homes. This could essentially lead them to them dying, but before they die, they will probably move on to another environment or another coral reef. So fish do look for their homes by the sounds of coral reefs, and they will swim to a healthier one.
Excellent. Thank you, Chandra. Now, another question: does climate change affect animals' future existence? Is that one you'd like to answer, Chandra?
Sure, I can answer it, but you're more than welcome to add in your thoughts. I definitely do think climate change affects animals' existence, including ours. I mean, if everything we're living with goes out of balance, then everything is affected, and it kind of causes a cascade effect. If you think of a pyramid, if a part of the pyramid is taken out, the rest of the pyramid will collapse, right, Walt?
Exactly right. That's an excellent analogy. I'm seeing one other question here before we move on. What are hard corals and why are they important for island resiliency? I'll give a quick answer and then Chandra, if you have anything to add. Hard corals are any coral that builds that hard, as we said, calcium carbonate or then limestone skeleton. And there's another question earlier in the chat, how are corals made? This sort of answers that. They take in calcium from the water. They produce calcium carbonate underneath them and in order to grow bigger, essentially. And this, over time, is what builds up these massive reefs. Coral are related, actually, to jellyfish. Believe it or not, even though they look totally different, they're made up of tiny little individual animals in a big colony. They're really cool. Why are they important for island resiliency? A number of reasons. As Chandra said, they've built up all the islands that we're living on here in the Cayman Islands, and they build up reefs around the coastline that protect the coast from storm damage and that kind of thing. Anything to add on that note, Chandra?
No, we're all good. Thanks, boss.
Excellent. Now, the reality is there are many ways in which nature helps mitigate carbon emissions and fight climate change. But these ecosystems need our help and they need our protection. And there are organizations just like CCMI that are working to do that, all over the world. In our case, through research and education. But when it comes to taking real action to protect our planet and our oceans, it's not just up to organizations and companies and governments. It's up to you and me. And there are a lot of things that kind of action can look like. It can look like biking instead of driving a car. It can look like avoiding buying things, we don't need. And, even the smallest of these kinds of actions can get big results, but only if we all take part. Would you agree, Chandra?
Exactly. Whether it's using less plastic or it's supporting sustainable seafood choices, even encouraging others to conserve the ocean, each one of those little actions do matter. This kind of reminds me, one of my favorite environmentalists, Baba Diom, once said that we will conserve only what we will love what we understand, and we'll only understand what we are taught. And this highlights the importance of marine conservation and education. The more people that love and understand the ocean, the more people are willing to protect it. So on that note, for everybody watching, let us know what actions you take to protect the ocean.
Thanks, Chandra. I'm going to have a look at the chat again now. Let's see if there's any good questions here. How can humans help the coral to not become bleached? Chandra, would you like to add anything about that? Or I may have some thoughts.
Well, we mentioned that bleaching is caused by environmental stresses like increased heat and acidity. So small actions that you can take at home to do this is, like Walter's mentioned, reducing your carbon footprint, making smaller sustainable choices. We have to work on decreasing the amount of carbon we use because the carbon is also helping heat the whole environment because of the greenhouse gas effect.
Thank you, Chandra. Exactly right. It's difficult to intervene directly to stop a coral from becoming bleached. Once it's bleached, some people have tried putting a shade structure over it to keep it cooler. But really what it boils down to is, as Chandra said, actions we take to reduce climate change and carbon emissions and get right to the source of the problem, which is warming oceans. But thank you for that question. I see one other question here before we move on maybe. How are mangroves able to hold and use so much carbon dioxide compared to other water plants? Chandra has any thoughts on that? You can add them. I will say for my piece, mangroves have the advantage that they're big. They're a tree, relative to other plants, and they sit, part above the water, so they have access to all the CO2 in the air, and they're not just restricted to using what's dissolved in the seawater. Anything to add to that, Chandra?
I also think it has to do with their tangled roots that can trap organic matter. So the roots that trap the organic matter obviously help in keeping the carbon storage.
Yes, excellent point. I see one other question here from Kaylee at RBPS. Up to what temperature can the ocean get to in a heat wave? They can get really hot. Hot tub temperature. I think in Florida recently, well no, in 2023 in Florida the water got up to, it was in the 90 to 100 degrees Fahrenheit range. Of course I'm American, so I don't know what that is in Celsius, but extremely hot is the answer. Another question from St. Ignatius, do fish help or hinder coral growth? And I think the answer could be a bit of each. Is that what you would say, Chandra?
Well, I definitely do think fish can help coral growth. They certainly need each other, especially herbivorous fish. They usually eat the algae that grow over coral. Now the algae can smother the coral and kill it, so with the herbivores eating that off, they are helping the coral grow. I'm not too sure of any ways that a coral or a fish could hinder coral growth.
I'll add too, just to get at the question. There are some fish that eat coral. Butterfly fish are one of them. It's usually not that big of an impact. It's natural. It's part of the ecosystem. Nowadays, those fish can also transport coral diseases, unfortunately, from one coral to another. If one coral is diseased and a butterfly fish takes a bite out of it and then bites another coral, that's the way those diseases can spread. But as Chandra says, really, we need healthy fish populations for healthy reefs. At the end of the day, we want strong fish populations for the sake of the coral and the whole ecosystem. Tim Carey says the Straits of Florida reach 98 degrees Fahrenheit, so that answers that question. Really hot. Thank you all for those excellent questions. Now, today, we're also giving you the chance to be part of something special, which is our DearTomorrow campaign. Chandra, can you explain a bit what that is?
Sure, so the DearTomorrow campaign, it's a very impactful way to send a message to the future. Now you can send promises to your future self, future generations, or even the ocean. And these promises can be anything from promising to use less plastic, promising to save energy, becoming a scientist, or even ocean advocate. So we want to hear what your promise would be. Let us know any of your DearTomorrow pledges in the chat, and we will read a few out just in a moment. But in the meantime, here is a video for some inspiration from CCMI staff and other students.
Dear Ocean, dear Ocean, dear future Ocean,
I promise to do all I can to protect you.
I promise to use my bike and reduce my use of fossil fuels.
I promise to use electric car.
I promise to turn off the lights when I leave every room.
I pledge to use less plastic.
I promise to protect you through science, action, and literacy. I promise to use my research to improve our knowledge about coral reefs.
I pledge to volunteer for beach cleanups to help our beaches stay beautiful.
I promise to choose businesses that support ocean-friendly practices.
I promise to learn more from you and do environmental education to inspire others how to love and how to protect our oceans. I promise to tell your story through my lens, to capture your beauty, to tell your battles and inspire others.
You can make a difference.
You can make a difference.
You can make a difference.
You can make a difference. You can make a difference. You can make a difference. You can make a difference. You can make a difference.
All of those pledges. Let's look again at the chat, see if people have any input there regarding pledges. Let's see, I'm seeing forwarded from Sir John A. Cumber Primary School. We refrain from littering the beach. We have beach cleanups as a school project to help prevent future damage to coral. We use reusable water bottles at school. Excellent to hear all of those. There's a question, what can I do to reduce my carbon footprint? Some of the ideas we've been talking about. Consuming less things you don't need, maybe driving less, turn off the lights, turn off the air conditioning when you don't need it. Anything to reduce the amount of energy that you use, in ways that reduce your carbon footprint. Eating less meat is actually one option. Very energy intensive to grow, to feed livestock. So excellent. I'll keep an eye on the chat there as we go. And thanks to everyone who sent that in. Now, the team we have underwater today are people who spend a lot of time in the ocean and therefore care about it deeply. And they also have some pledges they would like to add. So let's go down to them now and hear what they have to say.
For my DearTomorrow pledge, I promise to continue to educate about the marine environment and inspire people to love the ocean as much as I do.
I pledge to teach and share my love for the ocean and all the tiny creatures you can find that I see when I look through my camera lens when you slow down and take a closer look.
I promise to tackle issues such as overfishing by choosing only sustainable source seafood.
Thanks to all of you. For my part, I pledge to avoid buying things that I don't need and to reduce and reuse wherever I can to keep my carbon footprint smaller. And if you take away anything from today's episode, please remember that you can make a difference. Now, we are approaching the end of the time we have today. I hope you all feel inspired and empowered to be a part of the solution for climate change. And let's take a moment now to check in with our underwater team and see how they're doing. Chandra, how are you all doing?
We're doing swell down here, Bolt. I think we have a few more minutes for maybe one or two more questions or another pledge.
Excellent. Let me take a look at the chat in that case. We do have some pledges. Fred says, recycling, buying sustainable seafood, driving less. All excellent ideas. I promise to use less plastic. That's Jaden from MMPS Year 6. From CIS Grade 2, annually we educate our community of the importance of our ocean and what we can do to protect it. Very important. Excellent pledges from all of you. Thank you. Let's see. Chandra, should I look for some more questions here, or do we want to give a quick summary?
I think let's head over for a summary. So, we have spoken about climate change today. We got to explore some of the important roles the ocean helps in regulating the climate. We learned about ocean acidification and a cool experiment to demonstrate this. And we also got to have an introduction to CCMI's Blue Carbon Offset project. So quite a few things we learned about. And on behalf of the CCMI team, we would like to thank our sponsors, including Whitestone, and they have generously supplied environmentally friendly gifts to all the Camana Bay Cinema attendees today. We are very happy to partner with Whitestone and their commitment to the ocean. As we wrap up our last episode of the 2025 season, I would like to say thank you to everybody who have been supporting us throughout this series. We hope we've inspired you to take action and fight for our oceans. Now, last but not least, I want to say a very important and big thank you to the CCMI team, to our passionate educators, as well as our researchers and behind-the-scenes crew. We have had Greg, we've had Lowell, we've had Nicole, Luna, Justine, Lars, Ryan, Brenda, and all the other CCMI staff that has made this season possible. We couldn't have done it without you. But for now, we look forward to seeing you for the next 2026 Reefs Go Live season. But now we are going to say goodbye to all of you from the underwater team. Bye, everybody!
Thanks, Chandra. That is right. This is our last episode for the season. Thank you all so much for joining, You know, I apologize if there were any questions in here that I didn't get a chance to answer. There were a lot of excellent questions. Final shout out to happy birthday to Terry Powell from MMPS. Happy birthday. Excellent to have you all with us. Please do be sure to fill out, if you have the chance, our post-broadcast survey. There's a link in the chat. I believe there's also a QR code on the screen. And we do value your feedback here. In fact, our producer for today, Luna, is including the results of these surveys in her master's thesis. And while we're on that note, let's give a quick shout out to Lars and Luna, who are behind the camera on the boat today, as well as to Rob, who is keeping the cables from getting tangled, going over the side of the underwater team. Without all of them and all of the underwater team and all of our supporters, these episodes would not be possible. We will see you again next year here in Little Cayman, the lovely waters of Little Cayman. Until then, keep learning, keep fighting for our oceans. Goodbye, and have a great World Ocean Day.